Humanoid robots. My friends, the ChatGPT moment for general robotics is just around the corner. And in fact, all of the enabling technologies that I've been talking about is going to make it possible for us in the next several years to see very rapid breakthroughs, surprising breakthroughs in general robotics. Now, the reason why general robotics is so important is whereas robots with tracks and wheels require special environments to accommodate them, there are three robots in the world that we can make that require no green fields. Brownfield adaptation is perfect. If we could possibly build these amazing robots, we could deploy them in exactly the world that we've built for ourselves. These three robots are, one, agentic robots, and agentic AI, because they're information workers. So long as they could accommodate the computers that we have in our offices, it's going to be great. Number two, self-driving cars. And the reason for that is we spent 100+ years building roads and cities. And then number three, humanoid robots. If we have the technology to solve these three, this will be the largest technology industry the world's ever seen. Let me show you how that's done.
Developers around the world are building the next wave of physical, AI-embodied robots, humanoids. Developing general-purpose robot models requires massive amounts of real-world data, which is costly to capture and curate. NVIDIA Isaac GR00T helps tackle these challenges, providing humanoid robot developers with four things: robot foundation models, data pipelines, simulation frameworks, and a Thor robotics computer. The NVIDIA Isaac GR00T blueprint for synthetic motion generation is a simulation workflow for imitation learning, enabling developers to generate exponentially large datasets from a small number of human demonstrations. First, GR00T Teleop enables skilled human workers to portal into a digital twin of their robot using the Apple Vision Pro. This means operators can capture data even without a physical robot, and they can operate the robot in a risk-free environment, eliminating the chance of physical damage or wear and tear. To teach a robot a single task, operators capture motion trajectories through a handful of teleoperated demonstrations, then use GR00T Mimic to multiply these trajectories into a much larger dataset. Next, they use GR00T Gen, built on Omniverse and Cosmos for domain randomization and 3D to real upscaling, generating an exponentially larger dataset. The Omniverse and Cosmos multiverse simulation engine provides a massively scaled dataset to train the robot policy. Once the policy is trained, developers can perform software-in-the-loop testing and validation in Isaac Sim before deploying to the real robot. The age of general robotics is arriving, powered by NVIDIA Isaac GR00T.
Forgot my tools again. Such a show off.
Exciting work that is happening in AI and that we're doing ourselves as well is trying to use the rich data sources that we are generating now from all of our robots, whether they're deployed out in the real world, whether they're in our labs, or whether it's being generated in simulation, in order to train models that have a similar ability to generalize and a similar ability to error correct when trying to do fundamentally new manipulation tasks. And I think that's one of the places where I would expect AI to significantly change how we perceive the capabilities of robots over the next couple of years.
Atlas has cameras, mostly in the head, and with those cameras, it perceives the fixtures or containers that it has to interact with, not just the one in particular where it has to extract an object or insert an object, but all containers around it so that it can map its footsteps to avoid collisions, for example. And then at the same time, it also sees objects. It has an idea of the object that it's going to manipulate, and with that mental model, it sort of uses directly RGB cameras to estimate the pose of the object and then equally track it over time.
Boston Dynamics has a very long history in robotics, and in particular legged robots. And in bipeds alone, we've been working on them for probably over 15 years. But we really designed it to be a very high performance machine. And so we're interested in, again, being able to explore the very frontier of what's physically possible in humanoids. And everything, all the infrastructure we built around doing that, I think is a real accelerant that shows itself through the performance of Atlas already.
It's capable of all of the agility that HD Atlas had, but probably even more than HD Atlas.
pull our cars, the batteries, power electronics, the advanced motors, gearboxes, the software, the AI inference computer, it all actually applies to a humanoid robot. It's the same techniques. It's just a robot with arms and legs instead of a robot with wheels. And we've made a lot of progress with Optimus. And as you can see, we started it with someone in a robot suit, sort of down, and then we've progressed dramatically year after year. So if you extrapolate this, you're really going to have something spectacular, something that anyone could own. So you could have your own personal R2-D2 C-3PO. And I think at scale, this would cost something like, I don't know, $20,000, $30,000. Probably less than a car is my prediction long term.